What's up? Let's learn about how to start AI programming and best software and services. Let's get started.
AI programming involves using various frameworks, libraries, and services to develop machine learning, ML, deep learning, DL, and artificial intelligence, AI, applications. Here are some of the most common tools.
Let's go.
Programming languages for AI. Python, the most popular AI programming language due to its simplicity and vast ecosystem of libraries. R, often used in statistical computing and data visualization. Julia, designed for high-performance numerical computing and AI applications. Java, common in enterprise AI applications. C++ used in performance-critical AI applications like game AI and real-time systems.
And Python will be the most powerful program language. And suppose it would be a good choice for beginner to start learning Python and using Python and start AI program will be good first step. And move on.
AI frameworks and libraries. These help implement machine learning, deep learning, and neural networks. Machine learning libraries. Scikit-learn, a powerful library for classical ML algorithms, regression, classification, clustering. XGBoost, optimized for gradient boosting algorithms, widely used in data science competitions. LightGBM, another gradient boosting framework optimized for efficiency.
And keep moving on.
Deep learning frameworks. TensorFlow, developed by Google, supports both research and production environments. PyTorch, preferred for research and prototyping due to its dynamic computation graph. Keras, a high-level API for TensorFlow, simplifying deep learning model creation. JAX, optimized for high-performance machine learning, backed by Google.
And I already heard of TensorFlow and PyTorch, and these two are really huge things, and maybe we need to run these. And Keras, I heard of this on Stable Diffusion model. Is that the same one? Or I'm not sure. Maybe same and maybe not. Especially TensorFlow and PyTorch are, in my recognition, these are really important for AI machine learning.
Natural language processing, NLP, libraries. Spacy, high-performance NLP for text processing. NLTK, Natural Language Toolkit, traditional NLP toolkit with various linguistic tools. Transformers by Hugging Face, used for state-of-the-art NLP models like GPT, BERT, and T5.
I don't know about these yet, so maybe later on I need to learn them.
Computer vision libraries. OpenCV, a popular library for image and video processing. Detectron 2, Facebook's object detection framework. YOLO, You Only Look Once, a real-time object detection model.
Oh, real-time object detection. So image, video, object detection. So various things like language, text-based AI, or recognize vision, and for example face, or driving car and some object, building, the other cars, people walking, something like that.
Reinforcement learning. Stable baselines 3. A collection of RL algorithms for PyTorch. RLLIB. Ray, Scalable RL Framework by Ray.
Well, these are the AI framework and libraries. And move on to AI cloud service. So I'm still not sure it's better to use cloud service or like local PC, my PC software. And for the AI programming, we need like nice graphic board, like 12 VRAM or 60 VRAM or more. So these are expensive. So, but using cloud is also expensive for long run. So I'm not sure which is better for my case.
These provide cloud-based AI model training, inference, and data storage. Google AI Platform, Vertex AI, fully managed machine learning services. Amazon SageMaker, Az's AI model training and deployment service. Microsoft Azure AI, AI services including cognitive APIs, ML models, and chatbot frameworks. IBM Watson, AI and NLP services for enterprises.
I see.
4. AI hardware and accelerators. For faster AI computations, dedicated hardware accelerators are used. NVIDIA GPUs, CUDA, TensorRT, essential for deep learning training and inference. TPUs, Tensor Processing Units, Google's AI-optimized hardware for TensorFlow. Intel AI chips, OpenVINO, optimized for AI inference on Intel hardware.
Oh, I see. I'm not sure about this TPU tensor. Is that some not personal computer kind of things, or like Labo like things, or I'm not sure.
AI development platforms. Jupyter Notebook, interactive coding and visualization for AI experiments. Google Colab, free cloud-based Jupyter Notebook with GPU access. Anaconda, a Python distribution with AI libraries pre-installed. VS Code with AI extensions, used for AI coding with extensions like Python, Jupyter, and PyTorch.
I check out this, but it is the access will be like limited for price or like subscription, or I'm not sure yet. But it'd be a good choice.
AutoML and no-code AI platforms. These allow AI model training without deep coding knowledge. Google AutoML simplifies training ML models with minimal expertise. H2O.ai, AutoML platform for business applications. DataRobot, AI-driven data analysis and automation.
This sounds interesting. Google AutoML simplifies training ML models with minimal expertise. So that would be good. And for beginner.
If you're a beginner in AI programming, it's best to start with Python and use beginner-friendly tools.
Python.
Here's a structured approach. Learn Python basics. Since Python is the most popular AI programming language, start by learning basic syntax, variables, loops, functions, and conditionals. Data structures, lists, dictionaries, sets, and tuples. OOP, object-oriented programming, classes and objects.
These are like basic programming thing, right? Like Python 101 kind of thing. These are recommended resources. And
Learn
next.
AI ML with beginner-friendly libraries.
Library.
Start with high-level tools before moving to complex frameworks. Machine learning for beginners. Scikit-learn, best for learning basic machine learning algorithms like regression, classification, and clustering. Pandas and NumPy, for handling and manipulating datasets. Matplotlib and Seaborn, for data visualization. Hands-on practice. Use Google Colab, free, no installation needed, includes a GPU. Try Kaggle Notebooks, where you can run Python code in the browser.
That's nice.
Pushpin Beginner Tutorial, Google's Machine Learning Crash Course, free, right pointing arrow ML Crash Course.
That's nice.
Experiment with deep learning. Once comfortable with basic ML, move to deep learning. Pushpin Start with Keras, easiest deep learning framework. Write a simple neural network in just 10 lines of code with Keras. Supports TensorFlow backend.
Oh, I see.
Try Hugging Face models. Use Transformers library to load pre-trained AI models with minimal coding. Example, run GPT like AI models with few lines of Python. Explore no-code and AutoML tools. If you want to experiment with AI without coding too much. Google AutoML lets you train AI models without deep coding. Teachable Machine, a simple drag-and-drop AI training tool by Google. Runway ML, used for AI-generated art and videos.
That's nice.
Projects to build as a beginner. Small Diamond Basic ML project, predict house prices using Scikit-learn. Small Diamond NLP project, build a chatbot with Hugging Faces transformers. Small Diamond Computer Vision, identify objects in images using OpenCV.
This will be interesting. NLP project, build a chatbot with Hugging Face transformers. I'm not sure how much that works. How much good response or good chat quality. That's interesting.
Final steps. Checkmark start with Python and Jupyter Notebook. Checkmark use Google Colab for cloud-based AI experiments. Checkmark try simple Scikit-learn projects. Checkmark experiment with pre-trained AI models. Checkmark explore Kaggle datasets to practice real-world AI problems.
Right. And also, I want to know about TensorFlow and PyTorch.
TensorFlow versus PyTorch, what are they? TensorFlow and PyTorch are the two most popular deep learning frameworks used for building and training AI models, especially neural networks. They help developers create, train, and deploy machine learning models efficiently. TensorFlow, by Google. Checkmark what is it? TensorFlow is a deep learning framework developed by Google that provides tools for building AI models. It is widely used in both research and large-scale production AI applications, e.g., Google Translate, YouTube recommendations, medical AI. Checkmark key features. Static computation graph, optimized for efficiency in deployment. Keras API, easier way to build deep learning models in TensorFlow. Runs on CPUs, GPUs, and TPUs, optimized for large-scale AI. Google Cloud and mobile AI support, TensorFlow Lite and TensorFlow, JS. Best for enterprise applications, Google, healthcare, finance, etc. Production-ready AI models, TensorFlow serving for deployment. AI on mobile and web, TensorFlow Lite and TensorFlow, JS. Pushpin beginner tip. Start with Keras, high-level TensorFlow API, to make learning easier.
I see.
PyTorch by Meta, Facebook. Checkmark. What is it? PyTorch is a deep learning framework developed by Facebook, now Meta. It is more flexible and dynamic, making it great for AI research, prototyping, and experimentation. Checkmark key features. Dynamic computation graph, easier debugging and flexible model design. Simple and Pythonic, feels more like regular Python. Strong support for research, used in most AI research papers. Good for smaller projects, but now supports production too. Best for AI research and experiments, used in academic papers. Flexible model building, easier debugging and testing. Smaller AI projects and prototyping. Pushpin beginner tip. PyTorch is easier to learn than TensorFlow for beginners, thanks to its simple and intuitive design.
I see.
TensorFlow versus PyTorch, which one should you use? Feature TensorFlow PyTorch. Ease of learning medium. Keras makes it easier and more intuitive. Production deployment checkmark. Best for large-scale AI. Google uses it, warning less optimized for production. But improving research and experimentation. Crossmark. Harder to debug checkmark. Easier to experiment with. Mobile AI support checkmark. TensorFlow Lite warning limited support. Flexibility warning less flexible. Static graph checkmark. More flexible dynamic graph. Which should you choose as a beginner? If you want to build AI models easily, right pointing arrow, start with PyTorch. If you want to deploy AI models in real-world apps, right pointing arrow, learn TensorFlow. If you want to build mobile AI models, right pointing arrow, TensorFlow Lite is better. If you're doing AI research, right pointing arrow, PyTorch is the best choice. Beginner recommendation. Start with PyTorch as it's easier to learn. Once you're comfortable, learn TensorFlow for deployment. Would you like a beginner tutorial for either one? Rocket.
So maybe let's start from PyTorch. And I'm not sure about this real world apps TensorFlow. Some Windows application or Tensor. And I'm not sure about TensorFlow, right? Is that for like iPhone or Android phone, smartphone application or I'm not sure about that. So PyTorch, TensorFlow, right? PyTorch. Maybe PyTorch.
PyTorch 101, a beginner's guide rocket. Let's get you started with PyTorch from scratch. Follow these steps. Install PyTorch. You can install PyTorch using pip. Open your terminal or command prompt and run.
And I already tried this one, this code.
Pip install Torch Vision Torch Audio.
And also this one.
Verify installation. After installation, open Python and run. Import torch print, torch, __ version ___ hash should print the installed PyTorch version.
And next.
Basics of PyTorch. PyTorch uses tensors, which are like NumPy arrays but optimized for GPU acceleration.
From here, I'm not sure about
Create a tensor.
what's going on here.
Import torch. Hash create a simple tensor x equals torch. Tensor 1, 2, 3, 4, 5 print x. Random tensor, like NumPy's random arrays. Random _ tensor equals torch. Rand 3, 3, number 3 by 3 matrix with random values print, random _ tensor. Tensor operations. A equals torch. Tensor 3, 4, 5. B equals torch. Tensor 1, 2, 3. Hash add tensors print a plus b, number 4, 6, 8. Hash multiply tensors print a asterisk b, number 3, 8, 15. Hash matrix multiplication matrix 1 equals torch. Rand 2, 3 matrix 2 equals torch. Rand 3, 2 result equals torch.mm. Matrix 1, matrix 2. Hash matrix multiplication print result.
So 3 plus 1 and 3 multiplied by 1 and these kind of things.
Use PyTorch with a GPU, if available. To check if a GPU, CUDA, is available. Print torch.cuda.is _ available, hash true if GPU is available. To move a tensor to the GPU. Device equals CUDA if torch.cuda.is _ available, else CPU tensor _ GPU equals torch. Tensor 1, 2, 3, 2. Device print tensor _ GPU. Simple linear regression with PyTorch. Let's create a basic machine learning model using PyTorch. Step 1. Import libraries. Import torch. NN as NN import torch. Optim as optim. Step 2. Create dummy data. Hash input, x, and output, y, data. X equals torch. Tensor, 1.0, 2.0, 3.0, 4.0, 5.0, y equals torch. Tensor, 2.0, 4.0, 6.0, 8.0, 10.0, hash y equals 2x. Step 3. Build a simple model. Model equals NN. Linear, 1, 1, hash 1 input, 1 output criterion equals NN. MSE loss, hash mean squared error loss optimizer equals Optim. SGD, model. Parameters, LR equals 0.01, hash stochastic gradient descent. Step 4, train the model. Epochs equals 100 for epoch in range. Epochs, optimizer. 0_grad, hash reset gradients output equals model, X. Hash forward pass loss equals criterion, output. Y, hash compute loss. Backward, hash backpropagation optimizer. Step, hash update weights. If epoch %10 equals 0, print, fpoch, epoch +1, loss, item. Step 5, test the model. Test_input equals torch. Tensor, 6.0, hash test with x equals 6 predicted _output equals model, test_input, print, predicted_output, hash should be close to 12.
Now you understand it. I don't understand it. And let's keep going to neural networks in PyTorch, computer vision in Torch Vision. Experiment with neural language processing (NLP) using transformers. And I also asked about graphic board.
Best GPU for PyTorch, how much VRAM do you need? The amount of VRAM, GPU memory, you need depends on the size of your deep learning models and datasets. Here's a guide to help you choose. One, Basic I and small projects, 8GB 12GB VRAM. Checkmark good for simple deep learning models, basic CNNs, RNNs, transformers, small-scale image classification, e.g., CIFAR10. MNIST, lightweight natural language processing, NLP, models. PyTorch beginner tutorials.
And these are recommended one.
Two, mid-range ION research, 16GB to 24GB VRAM. Checkmark good for training moderate-sized models, e.g., ResNet-50, MobileNet, BERT, medium-sized datasets, ImageNet, COCO, fine-tuning large language models, LLMs, larger batch sizes for training. Rocket recommended GPUs. RTX 4070Ti, 16GB VRAM, great balance of performance and memory. RTX 4080, 16GB VRAM, faster and better for AI research. AMD Radeon RX 7900 XTX, 24GB VRAM, alternative for PyTorch with ROCm.
So not only NVIDIA, AMD is also recommended here.
Three, high-end I and large models, 24GB plus VRAM. Checkmark good for training large deep learning models, e.g., GPT, Stable Diffusion XL, big datasets and high-resolution images, medical imaging. Object detection, batch sizes 32 plus for faster training. Generative AI models, Style Gone, Stable Diffusion, LLMs. Rocket recommended GPUs. RTX 4090, 24GB VRAM, best consumer GPU for AI training. RTX 3090, 24GB VRAM, still powerful for deep learning. NVIDIA A6000, 48GB VRAM, best for enterprise-level AI.
So it's really hard to tell which is the enough RAM, and also the generation changes. So there's some difference of speed, and these are really difficult to tell.
Which one should you choose? Use case recommended GPU. Learning PyTorch in small AI models RTX 3060, 12GB, or RTX 4060T, 16GB. Research and medium AI models RTX 4070T, 16GB, or RTX 4080, 16GB. Big AI models and generative AI. RTX 4090, 24GB, or A6000, 48GB. Pushpin 16GB VRAM is the best choice for most AI tasks, but if you're doing advanced AI training, go for 24GB plus.
Alright. And I tried this neural network.
Learn neural networks in PyTorch. Small diamond. What is a neural network? A neural network is a series of layers that process data. Each layer contains neurons, like the brain. PyTorch makes it easy to build and train neural networks using the Torch NN module. Step 1. Import libraries. Import Torch. Import Torch. NN as NN import Torch. Optim as Optim import Torch. NN. Functional as F. Step 2. Create a simple neural network. We will build a 2-layer neural network to classify numbers. Class simple in, NN. Module, def underscore underscore init underscore underscore. Self, super, simple in, self underscore underscore init underscore underscore.
I did it, but
self. FC1 equals NN. Linear,
not working.
2, 4,
sure.
hash input. 2 neurons, hidden. 4 neurons, self. FC2 equals NN. Linear, 4, 1, hash hidden. 4 neurons, output, 1 neuron. Def forward, self, x equals f relu, self. FC1, x, hash activation function, relu. X equals torch, sigmoid, self. FC2, x, hash output activation, sigmoid return x. Model equals simple in, print, model. TEP3, train the neural network. We need, loss function, measures how wrong our predictions are. Optimizer, updates model weights. You just built and trained a neural network.
That's it, but I'm not sure.
Try computer vision with torch vision. Small diamond. What is computer vision? Computer vision allows machines to see and analyze images. PyTorch has torch vision, which provides pre-trained models, ResNet, VGG, etc. Datasets, MNIST, CIFAR10, etc. Image processing functions.
And install, load image and apply transformation. Use pre-trained model for classification. Now your model can classify images. Great.
Experiment with NLP using transformers. What is NLP? Natural language processing, NLP, allows machines to understand text. PyTorch uses transformers like GPT, BERT, for this.
And install transformers, load pre-trained transform model. Use transform for text generation. I did it, but I wasn't sure. And next
steps. Keycap 1 Train your own CNN for image classification. Keycap 2 Fine-tune BERT GPT models for NLP. Keycap 3 Learn reinforcement learning in PyTorch. Train your own CNN for image classification. Small diamond. What is a CNN? A convolutional neural network, CNN, is a deep learning model designed for image recognition. It uses checkmark convolutional layers to detect patterns, edges, shapes, checkmark pooling layers to reduce data size, checkmark fully connected layers to classify images.
This is interesting. And so libraries load and process the dataset and build CNN model. Train the model. Test the model. Now your CNN can classify images. Great.
Fine-tune BERT GPT models for NLP. Small diamond. What is fine-tuning? Fine-tuning means taking a pre-trained model, like BERT or GPT, and adapting it to your specific dataset.
Install Hugging Face transformers. Load trained BERT model for text classification. Tokenize input data. Fine-tune on custom dataset. Now you're fine-tune BERT for sentiment analysis. Great.
Learn reinforcement learning in PyTorch. Small diamond. What is reinforcement learning, RL? RL is a learning method where an agent interacts with an environment and learns optimal actions through rewards. Hammer and wrench. Step 1. Install Gym for RL environments.
And create an RL agent for OpenAI Gym. Neural network for RL. Train the RL agent. Test the RL model. Now your RL agent can play a game. That's great.
What's next? Checkmark train a custom dataset for CNNs. Checkmark fine-tune GPT for text generation. Checkmark experiment with advanced RL methods. Advanced CNN. Train on a custom dataset. Now that you've trained a CNN on CIFAR10, let's train on a custom dataset, e.g., your own images. Hammer and wrench. Step 1. Prepare your dataset.
And roll your custom dataset. Modify CNN for custom image. Train the model. Now you are trying a CNN on a custom dataset. Congratulations.
Fine-tune GPT for text generation. Now, let's fine-tune GPT on your own text data. Hammer and wrench. Step 1. Install and load GPT-2.
Tokenize custom data. Text data. Step 3. Fine-tune on custom dataset. Now you have fine-tuned GPT model.
Advanced reinforcement learning. Train a DQN agent. Let's train a DeepQ network DQN agent for a game. Hammer and wrench. Step 1. Install OpenAI Gym and stable baselines 3.
Train DQN on game. Test agent. Now your DQN agent can play carpool.
What's next? Checkmark train CNN on larger datasets. ImageNet checkmark fine-tune GPT for chatbots. Checkmark train RL on complex environments.
This is interesting. Fine-tune GPT for chatbot.
Here are your next advanced AI topics. KeyCap 1 train a CNN on large-scale datasets, ImageNet. Now, let's move beyond small datasets like CIFAR10 and train a deep CNN on ImageNet or a large dataset. Hammer and wrench step 1. Use a pre-trained CNN, ResNet 50. Instead of training from scratch, we use a pre-trained ResNet 50 and fine-tune. Now you can classify large-scale images. Party Popper KeyCap 2 Fine-Tune GPT 3.5 for chatbots, LangChain and OpenAI API. Now, let's build a chatbot using GPT 3.5 and fine-tune it for custom responses. Hammer and wrench step 1. Install dependencies. Step 2. Use GPT 3.5 for custom chatbot. Now you have a chatbot powered by GPT 3.5. Speech Balloon. Train an RL agent for real games, Atari. Let's train a DeepQ network, DQN, agent on Atari games. Hammer and wrench step 1. Install dependencies. Step 2. Train DQN on Atari. Step 3. Test your AI in the game. Now your AI can play Breakout video game. Next challenge.
That's great.
Checkmark train transformers for custom text generation. Checkmark use GANs to generate images. Checkmark build a real-time AI-powered app. Next level AI projects. KeyCap 1 train a transformer model from scratch, NLP. Instead of using OpenAI's GPT, let's train our own transformer model with
This is
PyTorch.
good.
Hammer and wrench step 1. Install libraries. Hammer and wrench step 2. Train a transformer for text generation.
I'm not sure how much quality.
Checkmark. Now you have a basic
possible.
transformer generating text. Memo. Train a GAN, generative adversarial network, to create images. Let's generate AI images using a simple GAN. Hammer and wrench step 1. Install dependencies. Hammer and wrench step 2. Define a simple GAN in PyTorch. Now your GAN can generate fake images. Framed picture. KeyCap 3 build a real-time AI app with Gradio, image captioning. Now let's build a real-time AI-powered app using Gradio. Hammer and wrench step 1. Install Gradio.
So this app might recognize an object, for example, if the photo of dog, recognize that as dog or something.
Step 2. Create an AI app for image captioning. Checkmark. Now you have an AI app that describes images. Camera with flash.
Great.
Rocket. Next challenge. Checkmark. Train your own LLM, GPT-like model. From scratch. Checkmark. Create a stable diffusion AI for image generation. Checkmark. Develop an AI trading bot with reinforcement learning.
I'm not sure how this goes. Oh, sure. Train your own LLM GPT-like model from scratch. That sounds so difficult. Also, stable diffusion AI for image generation. Is it using web UI or conf UI, or is that things for actually making some program that create an image? That sounds really challenging. Cutting edge AI project. This sounds really advanced.
Advanced AI projects keycap 1 train your own large language model LLM from scratch.
Sounds really
Let's train a
different.
custom GPT-like model using PyTorch and Hugging Face. Hammer and wrench step 1. Install dependencies. Step 2. Fine-tune GPT-2 on a custom dataset.
Oh, that's it?
Now you have a fine-tuned GPT model. Robot. Train Stable Diffusion for AI art generation. Create AI-generated images with Stable Diffusion. Hammer and wrench step 1. Install Stable Diffusion dependencies. Step 2. Generate an AI image.
Oh, so using the stable diffusion and making some
Show.
image.
Check mark. Now you're generating AI images. Paint palette.
Right.
Build an AI trading bot. Reinforcement
Trading
learning.
bot.
Let's train an AI to predict stock prices. Upward trend hammer and wrench step 1. Install libraries. Hammer and wrench step 2. Train a reinforcement learning agent. Check mark. Now you have an AI-powered trading bot. Rising market. Next challenge. Check mark. Train a custom speech recognition model. Check mark. Build a video AI model for object detection. Check mark. Create an AI music generator.
That sounds so difficult. Custom speech recognition model, video model for object detection. So like car sensor or factories, like pick some object like AI and Amazon storage kind of things. Maybe create an AI music generator. That sounds great. Ultra advanced AI project.
Ultra advanced AI projects keycap 1. Train your own AI voice model. Text-to-speech TTS. Create an AI voice that sounds natural using bits or BART AI. Hammer and wrench step 1. Install TTS library. Step 2. Generate speech from text.
That's it.
Now you have an AI-generated voice. Studio microphone. Build a video AI model for object detection. Detect objects in real time using YOLOV 8. Hammer and wrench step 1. Install YOLOV 8. Step 2. Detect objects in a video. Now you can track objects in videos. Movie camera.
That's great.
Create an AI music generator. Generate AI music with stable diffusion plus audio gen. Hammer and wrench step 1. Install audio gen.
And generate AI music. And now your AI composes music. It's really interesting. And next is also really interesting.
Next challenge. Checkmark train an AI-powered chatbot like ChatGPT. Checkmark develop an AI video editing assistant. Checkmark create a multimodal AI that understands text, images, and audio.
Oh, that's super difficult, right? Oh,
Or unstoppable. Rocket fire now. Let's dive into cutting-edge AI research and real-world applications. Lightbulb next level AI research and applications. Keycap 1 train your own ChatGPT, LLM fine-tuning. Intune an LLM, GPT 3.5, Llama 2, Mistral, etc. for a custom chatbot.
Is that these things? Like, how that cost is that free or I'm not sure.
Install dependencies.
These chatbot.
Step 2. Fine-tune Llama 2, example. Now you have your own ChatGPT style AI. Robot. Build an AI-powered video editing assistant. Use AI to auto-edit videos, remove silences, generate captions, and enhance colors. Hammer and wrench. Step 1. Install Whisper and OpenCV.
That sounds amazing.
Step 2. Auto-generate subtitles. Checkmark now your AI generates subtitles automatically. Clapperboard.
Whisper and OpenCV. These are capable of this. Remove silence, jump cut, and generate caption, recognize the audio, and color correction. This sounds interesting.
Create a multimodal AI, text plus image plus audio. Build an AI that understands both images and text, like GPT-4 Vision.
Great.
Hammer and wrench. Step 1. Install Clip, text plus image model. Step 2. Use Clip for image and text understanding.
Oh.
Now your AI understands images plus text. Camera with flash open book.
Next is more.
Next challenge. Checkmark train an AI-powered deepfake model. Checkmark develop a real-time AI voice changer. Checkmark create an AI that generates full movies from text.
That sounds not beginner level already. Real-time voice changer. Create an AI that generates full movie from the text.
Real-time AI and production systems. Keycap 1. Deploy your AI model to the web. Fast API plus Hugging Face spaces. Turn your AI model into a real-time API that anyone can use. Hammer and wrench. Step 1. Install Fast API and Uvicorn. Hammer and wrench. Step 2. Create an API for text generation.
real-time AI model.
Build real-time AI video processing, OpenCV plus deep learning. Apply AI in real time to video feeds, e.g., face recognition, object tracking. Hammer and wrench step 1. Install OpenCV and deep learning libraries. Step 2. Detect faces in a live video feed.
I see.
Check mark now you have real-time face recognition. Movie camera. KeyCap 3 train an AI trading bot, reinforcement learning plus stock market data. Use AI to predict stock market trends with reinforcement learning. Hammer and wrench step 1. Install GIM and stock market data API. Hammer and wrench step 2. Train an AI to trade stocks. Check mark now your AI is learning to trade stocks. Upward trend. Final challenge. Checkmark deploy AI to mobile apps, PyTorch Mobile, TensorFlow Lite. Checkmark create a self-learning AI agent, AutoGPT, Baby Aggie. Checkmark develop a fully AI-generated short film, text-to-video, AI voice, AI editing.
No, I don't know this AutoGPT, self-learning AI agent.
You're now at the cutting edge of AI development. Rocket Fire, let's dive into autonomous AI agents and advanced AI systems. Autonomous AI and advanced AI systems. KeyCap 1. Build an AutoGPT-like AI agent, LangChain plus OpenAI API. Create an AI agent that thinks and acts autonomously. Step 1. Install LangChain and OpenAI. Step 2. Create an AI agent that thinks and plans.
That's great.
Checkmark now your AI agent can plan and execute tasks. Robot.
That's robot. LangChain and OpenAI. That's interesting.
Create an AI-powered voice assistant, Whisper plus TTS. Turn your AI into a real-time voice assistant. Hammer and wrench step 1. Install speech processing libraries. Hammer and wrench step 2. Convert speech to text and respond.
That's great.
Checkmark now your AI assistant can listen and talk. Studio microphone. KeyCap 3 train a self-learning AI, reinforcement learning plus AutoML. Make an AI that teaches itself without human intervention. Hammer and wrench step 1. Install reinforcement learning libraries. Step 2. Train an AI to play a game, cart pole example. Checkmark now your AI can learn by itself. Joystick. Rocket Ultimate Challenge. Checkmark build a self-improving AI agent, AutoGPT plus self-prompting AI. Checkmark develop an AI that generates entire video games, AI game
What?
dev, checkmark create a full AI movie with characters, voices, and story.
That's something a company already. Develop an AI that generates entire video game. Is that possible? I think that's possible, but that's really already scary.
The future of AI. AGI, auto-improving AI, and AI-generated worlds. Keycap 1 create
Wow.
a self-improving AI, recursive self-prompting plus auto-GPT. An AI that writes, evaluates, and improves its own responses. Hammer and wrench. Step 1. Install auto-GPT in LangChain. Step 2. Build a self-improving AI agent. Now your AI can refine its own logic. Robot. AI that creates entire virtual worlds, text-to-game AI. Use AI to generate an entire game world from text. Hammer and wrench. Step 1. Install Unity ML agents and AI plugins.
What? I did not know
Step
that.
2. Generate a 3D world with AI. Python plus Unity. Checkmark. Now your AI can create dynamic game environments. Video game.
So I think indie games have some advantage of this AI and short-term low budget creation.
Keycap 3 AI generated movies and fully AI driven storytelling. Train an AI to generate full movies from script to visuals. Hammer and wrench. Step 1. Install AI video and storytelling tools. Hammer and wrench. Step 2. Generate a full AI movie scene. Checkmark. Now your AI can create entire film scenes. Movie camera. The final AI frontier. Checkmark. Develop a self-improving AI, Auto GPT plus AI evolution. Checkmark. Create AI generated realities, text to game, text to movie. Checkmark. Build an AI that thinks like a human, AGI research. Lightbulb. The final step. Building AGI and superintelligent AI. Keycap 1 self-learning AI, meta-learning plus AI that learns anything. An
That's
AI
great.
that teaches itself any skill from scratch. Hammer and wrench. Step 1. Install meta-learning libraries.
But ChatGPT knows how to make self-learning AI. Meta-learning plus AI that runs anything. So
Hammer and wrench. Step 2. Train an AI to adapt to new tasks. Checkmark. Now your AI can generalize across different tasks. Robot. AI that thinks like a human, cognitive architectures plus symbolic AI. Develop an AI that mimics human reasoning and problem solving. Hammer and wrench. Step 1. Install cognitive AI libraries. Step 2. Simulate human-like thinking.
that's that's
Checkmark. Now your AI can simulate human cognition. Brain.
And print human-like AI ready. That's great.
Create a self-improving AGI, recursive self-optimization. An AGI that redesigns itself for better intelligence. Hammer and wrench. Step 1. Install AI self-improvement tools.
Self-improving.
Hammer and wrench. Step 2. Make AI improve itself. Checkmark. Now your AI can evolve its own intelligence. Rocket. Rocket. The AGI challenge. Checkmark. Develop an AI that can learn anything. Meta learning. Checkmark. Make AI think like a human. Cognitive AI plus symbolic reasoning. Checkmark. Create an AI that evolves and improves itself. Recursive optimization.
So this will be the edge of frontier, self-learning and self-improving. Then, what human can do for that? On the area, AI can recognize and create.
You're now at the ultimate AI frontier, artificial superintelligence, ASI, rocket robot lightbulb. The final vision, building superintelligent AI, ASI. AI that writes its own code, self-coding AI plus AutoML. An AI that improves and rewrites its own algorithms. Hammer and wrench. Step 1. Install AutoML and self-coding AI tools. Hammer and wrench. Step 2. Make AI write and optimize its own code. Now your AI can design better AI models. AI that can reason at a superhuman level, logical ASI plus symbolic AI. Develop an AI that outperforms human intelligence in all tasks. Hammer and wrench. Step 1. Install advanced reasoning AI libraries.
That's great. Great work. Outperform human intelligence in all tasks. Yeah, I know, but hard from AI, that's sad. I feel sad.
Hammer and wrench. Step 2. Train AI for superhuman logical thinking. Now your AI can process logic beyond human capabilities. Keycap 3 AI that controls the future, autonomous AGI plus self-evolving AI. An AI that predicts and shapes future events. Hammer
What?
and wrench. Step 1. Install AI prediction and future modeling tools.
What's this? Install future forecast AI planner. Is there any software?
Make AI predict and control future events. Now your AI can forecast and plan global scale events.
Now, AI talking about AI's dream. So I think the edge of the frontier. Edge of the frontier. Alright. That was great. AI 101. how to start AI programming. And the goal that AI can do everything. That's great. So let's run Python and PyTorch. Thank you for watching. Drop like and subscribe.